I lived many years in tropical Africa. And one day, out in the bush, back in the 1960s, I got blood poisoning. Don't ask how, it's a stupid way. But had it happened just 20 years earlier, that could have killed me. But I went along to the local field hospital, one big jab of penicillin in the backside. Didn't like it very much, but I was fixed. It cured me. The archetypal magic bullet. And today we can fix just about anything that nature throws at us. So what is left? Well, what is left is not what nature does to us, but what we do to ourselves. They're the self-inflicted diseases. The cancers, the heart disease, the osteoporosis, the arthritis, the dementias, and many, many more. And they're due to the mismatch between the lifestyle designed for us by our evolutionary past and the way we live today. Now, when I was back at university back in the 1960s, we didn't have much of a clue about what the human origins were and what might be the right kind of lifestyle. It never even occurred to us to ask the question. I was taught that the Europeans were descended from Neanderthals who were around in Europe for 1 million years, that the Chinese were descended from the Peking man who was around for 1 million years, and these were different creatures, and that somehow simultaneously in various parts of the globe these creatures all turned into human beings, modern Homo sapiens. And I didn't buy into this, it didn't seem to me very likely at all. And bit by bit though, over the 60s and 70s we had people like the Leakeys out in East Africa digging up bones, suggesting, these were very ancient bones, suggesting that indeed humans had their origins in Africa somewhere, perhaps in East Africa. But the confirmation, the clincher, came from a totally unexpected quarter, one that we had absolutely no idea was going to be coming to us, and that was the study of genetics. And then it was that we discovered, and this happened not until the late 1980s now, we discovered that everybody on this planet, from the Eskimo to the Australian Aboriginal, is descended from a small group of people who lived just 60,000 years ago, just 3,000 generations, in the savannas of East Africa. And this is our homeland. And we are all, after all, still tropical creatures. We still need the sunshine. Sure, we've changed on the outside a little bit since then, but underneath we're still the same basic model. And the important thing is to know we have the same digestive systems, the same biochemistries, the same biologies, the same mentalities as for life on the savannas of East Africa. That is our homeland. Okay, so this is Mount Kilimanjaro, and you've got the elephants and you've got the open savanna lands. This is a baobab tree which provided the fruits that people back then would have been eating and still provides fruit to people eating today. And we've got the flamingos and the warthogs and the ostriches and so forth. And this is a typical sort of savanna scene too, which shows animals peacefully grazing, the open grasslands and the occasional trees. And the interesting thing is that if you show this kind of picture to people all over the world, different kinds of cultures, and compared to seascapes or cityscapes and so forth, they find this the most reassuring, the most pleasing. The evolutionary psychologists have got into this to find out perhaps what's going on, and after all, if the animals are peacefully grazing, probably doesn't mean there are any nasty predators around. You've got the open sight lines, so if any hostile humans are coming at you, you can see them very quickly. And you've got trees to shin up if you need to. This is a kind of pleasing landscape for us. And what do you know? If you have the chance to build your landscape which you find most pleasing, then you come up with something very similar. Hey, this is an English country park of which many were designed over the centuries, with the animals peacefully grazing, the open grasslands and the occasional trees. And we'll come back to this theme a little later. Now, just thinking about people who still live that way, back there in that kind of environment, these are some sand bushwomen collecting berries. They've got the babies on their backs. And here's a sand bushman, he's setting a trap. And half a world away, you have the Australian Aboriginals still living that kind of lifestyle too. This chap has just caught a wallaby. Now, you might ask, what was their health like? Well, they didn't suffer from cancers, heart disease, osteoporosis, arthritis, dementias, and all these things that we rightly call diseases of civilization. But let me just give you a couple of health signs. If we look at cholesterol, everybody's kind of worried about cholesterol, aren't they? if we look at how much cholesterol the average Westerner eats, then it's about that. And the target that we're told by the medical authorities is to eat less cholesterol, somewhere down there. But we find that foragers are actually eating more cholesterol than the average Westerner. Just quite naturally, it's what occurs in the diet, in the foods that they're collecting and they're eating. And yet, when you look at what's happening in the blood serum level, what's in the cholesterol in the blood, well, the Westerners are right up high. We have the Western target, which is a little bit lower, but foragers have much lower cholesterol levels, quite naturally. And the reason is that their bodies aren't making cholesterol. We're going to get into this a little later on, that our bodies are making cholesterol under the dysfunctional lifestyles we're leading, rather than because we're eating it. In fact, it gives the lie to the idea that controlling your cholesterol intake will control your cholesterol levels. It won't. It's because you have to stop your body making it when it shouldn't. And we'll look at just one other vital sign, blood pressure. We're fairly used to the idea that blood pressure increases with age like that, but not with foragers. It stays horizontal. They have good cardiovascular fitness. And the same thing with diastolic blood pressure too. In fact, if anything, it tapers off with the foragers. So how did they live back then? Because this is the key to the question. Well, they lived in groups of 40 to 50 people, 12, 13 families, that kind of thing, and they would have a territory of about 200 square miles within which they wandered. They would camp for a while in one place, and when they were done there, then they'd walk 10, 15 miles to the next place and camp there, and so it would go on round and round through the seasons. Now every day, the women would be going off as a group, foraging, collecting the berries like we saw. They would be certainly collecting other kinds of things. They would be digging up underground foods, roots, yes, tubers, that kind of thing. The men would be going off most days, trapping, maybe hunting, more often scavenging, trying to get whatever was left of a zebra after a lion and had finished with it, but having to fight off the hyenas and the vultures for it too. And when the men brought back their food stuff, they would eat everything, the blood, the brains, the guts, the whole works. And the women would be coming back, and they would be providing, by the way, something like 85% of the food supply for the band, for the family. They would be coming back with something like 15 to 20 pounds a day of collected foods, most of which was plant food, like I've just discussed. But also it would be animal matter that they could collect with their bare hands. They would bring back tortoises, snakes, lizards, snails. They would be bringing back and so forth, earthworms, that kind of thing. And I'd sometimes stop right there because people say to me, the guy's crazy, he's telling us we've got to eat frogs and snails and puppy dogs' tails. Well, I'm not saying that, although the French do come pretty close. What this does, it gives us a profile, which if we can emulate it in today's world, then we're putting the right kind of gas in the tank, as we say in America, that we're getting the right kind of fuel specification. And the good news is it is possible, in fact it's quite easy, you just have to know what you're doing. Now we'll come back to this topic a little bit later, but what I want to get onto now is another aspect of lifestyle. When you think about these peoples, they were living stark naked 365 days a year under a tropical sun. And if this was the case for eons, you can be sure our bodies came to rely on it being there. And if it isn't, then things start to go wrong. And today we now know that in the Western world, people are suffering terribly from sunshine deficiency. All right, we all know we like a little bit of sun, but we're actually suffering physically from it. If you imagine you're inside, you're indoors and the sun's not getting through, if you're sunshine deficient, then it is a factor in a whole range of conditions, from osteoporosis to depression, mood disorders, multiple sclerosis to dementias to heart disease, asthma, diabetes and cancers. Now, this is goes against a lot of the common wisdom that is being put out at the moment, and I'm just waiting for the sunscreen manufacturers to have the class action lawsuits against them for creating so many sick people by persuading them to use all this sunscreen and to be freaked out about sunshine. But the tide is turning. In the last few years, the British Medical Journal has been having a lively debate about, well, maybe we've been just a little overzealous in telling people to be careful of the sunshine. After all, people are now being sick because they're not getting enough sunshine. They're not getting, yes, it's vitamin D is probably the big one we all know about, but there's so much else going on, some of which we can only half understand. It's to do with strengthening the immune system, it's to do with strengthening mood. Of course, we all understand about sunlight and how important it is for our mood and so forth. So the British Medical Journal itself is having this debate and thinking, well, maybe we've gone a bit too far on this. But even better, a consortium of 7 major health institutions in Britain, includes the cancer people, the heart disease people, the dermatologists, have come out with a statement, amongst other things, which says that we recommend that British people should get out into the sunshine at midday for at least 10 minutes. Provided there is sunshine, get out there for at least 10 minutes and without sunscreen. Sunshine is a piece of human nutrition, and we ignore it and don't have it at our peril. It undermines our health. The second thing I'd like to talk about our lifestyle is to do with physical activity. These people had a fair amount of physical activity. For example, these bush women are carrying firewood as it happens, but they would walk something like, on average, 4 to 5 miles a day, carrying the babies on their backs, the toddlers. The toddlers, by the way, refuse to toddle until they're forced. They're carrying the babies on their toddlers on their backs, and they will be carrying the firewood, and they'd be walking 4 or 5 miles a day. And this happened day in, day out, almost without ever stopping. But they were only doing it for 4 or 5 hours in every day. Similarly, the men would be heading off. They would split, these guys are going to split up in a minute and go off and just set their traps or go chasing after the wallabies or whatever it is, or more likely the warthogs. And they would be perhaps walking rather more, 7 or 8 miles a day, not every day of the week, sometimes running. Sometimes they would run for hours and hours and hours if they were tracking down some wounded animal that was trying to get away from them. And of course, as I've just said, everybody had to walk 14 or 15 miles from time to time when they were going from one campsite to the next. If this was the level of physical activity that was going on all down through the eons, you can be sure our body came to rely on it being there. And if it isn't, things start to go wrong. And we kind of know this, don't we? That physical activity is good for us. Well, what I'd say is the absence of physical activity is bad for us. So I'll try to look at it the other way around. And I'll just cite a few examples that you may not have thought of. Our heart does a pretty good job of pumping blood around the body, except in the lower leg. For some reason, it doesn't do a good job in the lower leg. Astronauts have problems with circulation in the lower legs. Bedridden people have problems with circulation in the lower leg. Why might this be? Well, because it never had to bother so much about circulating down there, because it could rely on us walking about like this, and this action is pumping blood through the lower leg all the time. Walking, it assumes that walking is going to be there as part of keeping our circulation going. We have another circulatory system, the lymphatic system. That doesn't have a pump at all. The lymphatic system is vital for carrying down immune system cells, down to fight cancers, down to fight infections, carry away the toxic waste. That doesn't have a pump at all. It relies entirely on us moving our muscles to keep that lymphatic system moving. And if we don't do that, then it stagnates, it gets sick, and we get sick with it. And obviously sometimes it even gets cancerous. Astronauts, for example, lose 4% of their bone mass for every month they're in space. Doesn't matter how many calcium tablets they swallow. Why? Because they're not getting that kind of physical activity, gravity-loaded physical activity, which is triggering signals in the bone-building cells to tell them, hey, keep building, keep repairing, keep working. And then there's the sheer business of doing physical activity changes hormonal responses. Ones which are to do with glucose control, ones to do with cholesterol control, ones to do with mood control. And if you don't have the physical activity, you're more likely to be diabetic, you're more likely to have mood problems, depressions, and so forth. So yes, physical activity is a vital part of human existence, but it doesn't have to be necessarily highly intensive. For example, golfers regular golfers, these are people who play 4 or 5 times a week, live 4 or 5 times longer than people who are non-golfers. That doesn't mean to say that's the only answer to it, is to play golf all the time. But the interesting thing is that it's the one case where we find that male golfers will outlive their spouses, their wives, who are non-golfers. Nearly always otherwise, it's the other way around. As we know, women do tend to live longer than men, except when the man is the golfer and the woman isn't. But what do you know? These people are walking 4 to 5 miles a day. If they're sensible, they're carrying their bags. And they're in the sunshine, and they are in an environment which looks just like an English country park, which is a proxy for our homeland. Right, so let's think quickly about the big one, the food supply. People were eating quite a lot of plant food of a particular kind. They're eating 2 to 3 pounds a day, like 3, even more, that kind of thing. And it had the particular characteristics. First of all, it was rich in micronutrients in a way that other creatures don't need. Certainly our cousins, chimpanzees, gorillas, also need a rich micronutrient diet. And the problem in today's world is we're eating food supply which is poor in micronutrients. We'll see how that happens later. It's nothing to do with the way the foods are grown or the poverty of the soils. It's because the types of foods are poor in micronutrients. But just to give an example, this woman on the left is got poor micronutrient status, and this one on the right, she has good micronutrient status. And we can see most people would regard the woman on the right as being more attractive. This would be our brain detection mechanism saying, hey, this woman is fit for purpose. She has good micronutrient status, she is healthy. Another feature of this plant food is that it was rich in fibre. Yes, the soluble, insoluble, downright indigestible fibres. Now, again, this is something to which our digestive system is designed for. It expects to receive this high throughput of plant food, particularly fibrous plant food. And most importantly, and this is a much neglected topic, it is feeding. The residues are feeding a biomass down in our colons. And this biomass, which is bacteria and funguses and so on, most of the funguses and viruses that are down there are hostile, but the bacteria, if everything is working right, are what they call commensal, are friendly, are helping us. This biomass down there is supposed to be, and the body expects it to be, working in symbiosis with us, helping our body biochemistry. We provide we host, if you like, the place where these bacteria can be, and they repay us by doing good things for us. They, for example, are producing various kinds of chemicals which get through into our bloodstream, like propionic acid, butyric acid, which are part of keeping our biochemistry functioning properly, in particular the immune system, and also involved in cholesterol control. One of the little areas where our cholesterol control can go haywire. These good bacteria are sending little instructions out towards, involved indeed with glucose control too. And they're involved in all kinds of control mechanisms with the little signals they're sending out. One of the most fascinating things they're doing is actually cross-talking with immune system cells on the other side of the colon wall and helping them to mature properly. And these good bacteria are fighting off bad bacteria, because like anywhere else, it's a war zone, and the bad bacteria are still trying to get a muscle in on the action. So that's when everything's working as it should do. But of course, what we do today is send down the wrong kind of residues which feed bad bacteria, and these bad bacteria haven't got our health at heart, they've got their own interests at heart. And so they're not doing all these good things. They're not creating these chemicals that get through into the bloodstream. They're not keeping the colon wall nice and tight. That's another point. They keep the tight junctions tight. They make it leaky so that they can sneak through into our bloodstream and into our lymphatic system and create mischief there. And they're not cross-talking and educating our immune system either. That's not in their interest. They want a weaker immune system. And finally, these bacteria are what are often called sulfanogens. They are sulfur-producing bacteria. They are the ones that produce that smelly gas, hydrogen sulfide. They produce sulfuric acid, and these are poisonous substances. And right here, down there, they are making these substances in our colons And right there you can see a trigger, a factor in all the kinds of colon diseases we hear about: irritable bowel, colitis, inflammatory bowel, and so on. Of course, it ultimately can lead to cancers, and you get other kinds of bowel diseases too. So the right kind of residues is, again, the right kind of plant food residue is a vital part of keeping our overall health in good shape. And believe me, those sand bushmen have great colon health. Most of the people in the West have very poor colon health. Finally, this plant food is what we call alkalizing. That is to say, when it's absorbed into the body, it basically alkalizes the body fluids, whereas other kinds of foodstuffs, particularly animal meat, would acidify the body. Fair enough, this is part of the give and take that goes on all the time. And when we're eating a lot of plant food which is not dense, whereas animal food is dense, and the two kind of balance each other out. And that's how it should be. Human biology is designed to work with a broadly neutral effect, if not slightly alkalizing. Whereas cats, for example, are designed to work perfectly well on an acidifying diet, whereas giraffes or cows are designed to work on an alkalizing diet. Well, what we do today is have an acidifying diet, mainly because it's the plant food we're eating isn't alkalizing. And this does things like draw calcium from the bones to equalize out the acidifying effect. It builds kidney stones, and it undermines various organs like the pancreas, the lymphatic system, the thyroid, and even the liver and other things too. So this is all part of a picture, if you like. We all understand how this works. We all know that salt is not great, don't we? Kind of, yes. The only salt in these forager diets, in our ancient ancestors' diet, was what was intrinsic, or if you like, sodium that was intrinsic, was what was intrinsic to the foods they were eating. There wasn't any free salt anywhere. It was purely in the plants and in the animals they were eating. It wasn't a lot. There was some, but not a lot. But what's interesting is that there is a ratio between sodium and potassium, which turns out to be quite important in our biochemical terms. And if we get that wrong, well, other things are being undermined. Like at the cell level, in the cell, the cells are busy having to pump out sodium out of the cell and bring potassium into the cell. Now, this works fine, so long as there isn't too much of a gradient against which the pump has to work. Now, if there's a lot of sodium outside the cell already, then it can't do it. It can't evacuate the sodium out of the cell, and it sickens and dies. In other words, we're undermining our health in all kinds of little ways. Little ways, but all these things add up. And just to remind you, since we've mentioned it, that salt, yes, you have too much salt, it is doing things like, yes, increasing blood pressure for many people, particularly if they're low in potassium. And potassium, by the way, comes from plant food of the right kind. If it is, so it's antagonistic to calcium. It is, and it depresses the immune system, and it creates all kinds of mischiefs. It's very aggressive to the arteries when you have excess salt in the diet. So we have a blood sugar levels, and blood sugar is vital for keeping our bodies working properly. It's the energy source on which they work. But it has, and the blood sugar levels have to be within very tight limits, because excess blood sugar is very damaging, and when you don't have enough, you go into a coma and die. So the body's got very good mechanisms for doing that. And the red line there at the top is the maximum where it should be, and the minimum, and the red line, below red line, is the minimum where it should be. Now, these red lines are kind of drawn as a matter of judgment by various bits of research. I think they're probably spread too far apart, but never mind. If we're eating a diet where you absorb something which becomes increases glucose levels. This is the kind of thing it does when it is a normal thing to be eating. Whereas what we're doing today in the Western world is consuming a diet which does this kind of thing. It produces sharp blood sugar spikes, and then it overcompensates, and you go down into a hypoglycemic. This is the one, hypoglycemia, this is the one where you suddenly feel, feel tired. You would walk through a brick wall to get a Mars bar. You may feel irritable, you may have a migraine or something, headaches. You feel bad because you're down in that hypoglycemic. Whereas the other one up there, the hyperglycemic, where you've got too much blood sugar in the bloodstream, it's called hyperglycemia, that you don't feel. But it's doing a lot of damage. It's damaging nerve endings, it's damaging the retina of the eye, it's involved in liver disease, and worst of all, it is feeding cancers. Cancers feed on blood sugar, and the more of it is, the better the cancers grow. Now, that doesn't stop there, the mischief. To control these high blood sugar levels, the body secretes the hormone insulin. It secretes insulin up here to tell the fat cells to drag sugar out of the bloodstream, store them as fat, bring the blood sugar level down. But it has to secrete exceptionally high levels of insulin to deal with the exceptionally high levels of blood sugar. So let's just look at the typical insulin secretions if you have a forager meal. Would be like that, and that's the insulin levels in the bloodstream over a period of a couple of hours. And this is the insulin levels secreted if you eat a modern meal, which is a high glycemic one which gives you the sharp blood sugar spikes. And you could say that the difference between the two is a state of hyperinsulinemia or abnormally high insulin in the bloodstream. Now, insulin is a powerful hormone which, when it's there in excess quantities, is like a bull in a china shop knocking over all the furniture. I like to think of it like an iceberg. You don't feel or see anything underneath the surface, but just see above various what you think are unconnected conditions. This is what it looks like. So there's your iceberg with the hyperinsulinemia. You don't feel anything, but when you're in that state, it is doing things like giving you the postprandial slump. This is when you feel all sleepy after you've had a high glycemic meal in the afternoon. You suddenly feel sleepy after lunch. It's involved in dementia. It's a factor in dementia. It's a factor in depression, in arthritis, in inflammatory bowel. It's very inflammatory in general, in fact, a high insulin. It depresses the immune system, which then allows cancers to flourish. And I will just quickly say, the main reason, just while I've been talking to you, you've had half a dozen cells go precancerous. Why is it we don't all break out into tumours? The answer is that we've got, over the eons, our bodies have developed defences against these cancers. And these defences are basically called the immune system in all its various guises. But when we depress the immune system, then we start to allow cancers to break through. The high glycemic diet, the hyperinsulinemia, is one of the ways in which we're allowing cancers to become so prevalent today. It's directly involved, of course, in obesity and diabetes, the condition when you've lost control of your blood glucose. It's involved in depressing bone building. So it's a factor in osteoporosis, and it's a factor in a whole range of cardiovascular diseases. For example, insulin increases production of thromboxane, which is a very powerful blood clotting hormone, so that you then end up making blood clots more easily. It's involved in thromboses, in heart disease in general, in hardening of the arteries, hypertension, and it's one of the major ways by which we make extra cholesterol. When we think back to those Sand Bushmen, why it was that they didn't have high cholesterol levels, it's because they weren't eating a high glycemic diet. One of the reasons, and one of the main reasons I would say. What happens is insulin triggers the liver into manufacturing cholesterol when it's not needed, not wanted.